Greetings. This is Amara again. Welcome to today's study session on Python Dictionary Basics. Recall from the overview that there are 4 basic collections in Python: lists, tuples, sets, and dictionaries. Our focus today is dictionaries. Also, recall from the overview that there are 3 key properties of Python collections. A collection can be ordered or unordered. A collection can be mutable or immutable. And a collection can be heterogeneous or homogeneous. Our learning objective today for the study session is to understand how the 3 key properties of collections apply to Python dictionaries. As we proceed, keep in mind that Python dictionaries are unordered, mutable, and heterogeneous collections. Let's begin with an intuitive understanding of a Python dictionary. We will then use our intuition to state a definition. Whenever you think of a Python dictionary, think of a key-value pair. The pair always go together. The key is used to unlock or obtain the value. Let's consider a simple example. Suppose I want to know an employee's salary. I might have stored salary information of all employees in a Python dictionary called salaries. Suppose I want to know Roger Rabbit's salary. By providing the name, the key, I can retrieve the salary, the value. Note that dictionaries are one-way or asymmetric, by which we mean that we can use the key to obtain its corresponding value. But we can't go the other way. We can't go from values to keys. We should also note that keys are unique. Each key appears in the dictionary only once. However, 2 different keys can map to the same value. In our example, Roger Rabbit and Goofy map to the same salary, namely 5,000. In summary, we can think of a Python dictionary as a lookup table. Given the key, I can look up the corresponding value. As lookup tables, they are analogous to ordinary dictionaries, which is a mapping of words to meanings. Our roundabout excursion has brought us finally to our destination. We can define a Python collection as an unordered collection of key-value pairs. Wonderful. Let's get to it. Let's go to Python. First, let's see how we create a dictionary in Python. We will create a new dictionary called authors. The key will be an author. The corresponding value will be one of their notable writings. We define a dictionary using curly braces. Inside these braces, we place our key-value pairs. The author names are the keys, and a notable book they have written is the value. Each key-value pair is separated by a comma. Now that we have defined a dictionary called authors, let's see how we can obtain a particular value from a key. To access the books written by a specific author, we use the author's name as the key. To obtain a particular value from a dictionary, we first write the name of the dictionary. In our case, the dictionary is called authors. Then, we insert the name of the author inside square brackets to retrieve the associated value or book. Dictionaries are mutable, which means that we can add and delete items from a dictionary. Let's expand our dictionary by adding George Orwell and his famous novel 1984. There are several ways to add a new entry to the dictionary. One approach is to write the dictionary name followed by the new key in square brackets and then assign the corresponding value to the expression. If the key doesn't exist already in the dictionary, it will be added with the assigned value. If the key already exists, the previous value will be updated with the new one. This method is very efficient for adding individual elements or updating them. How can we delete a key-value pair from a dictionary? It's easy enough. Suppose we want to remove James Joyce from our collection. We do this using the del statement. James Joyce has now been respectfully removed from our authors dictionary. Let's finish up by taking a global look at a dictionary. To list all the authors or keys of a dictionary, we can use the keys method. Similarly, to obtain all the values in the dictionary, we use the values method. Finally, we can use the items method to list both the keys and values of the dictionary. A final note. We mentioned 3 important properties of Python dictionaries: unorder, mutability, and heterogeneity. Dictionaries are unordered in the sense that elements don't have a position relative to other elements. We have also seen that dictionaries are mutable. This means that we can add, delete, and replace elements in a dictionary. Let's turn to heterogeneity. Heterogeneity means that we can add data of different types to a dictionary. This has been implicit in our example. But now let's make it explicit. Our original example of author consisted of the key being a string, the name of the author, and the value was also a string, the name of a notable book written by the author. But let's consider an example where the key is still a string, but the value is now a list of books by the author. Our new author dictionary consists of 2 entries. The key Toni Morrison corresponds to a list containing 2 of her books. The key Jane Austen also corresponds to a list containing only 1 of her books. Let's update the entry for Jane Austen by adding another book, the book Persuasion. Good enough. As you continue with your study of Python, you will discover that dictionaries are extremely powerful data structures. Dictionaries are related to hash maps, also known as hash tables. Hash maps are the underlying implementation for data dictionaries in many programming languages, including Python. That concludes our study session on Python dictionaries. I am so pleased that you joined us. Once again, this is your host Amara. And I hope to see you again soon for another study session in Python.